Hi guys, welcome back. And this is now our second example for material balances involving reactions. Okay, so meron tayo ditong reactor and the feed to the reactor is chlorine and C3H6. So this is some kind of alkyl chloride chemistry and ito yung reactions na sa blue. Okay, so we have reaction 1, okay, and reaction 2. So these two reactions, kung titignan mo, isa siyang type of parallel reaction no, between chlorine and C3H6. Okay, so parallel reaction po siya. Now, after the process, nalaman natin na ang product ay mayroong composition na nakasulat dito sa ating screen. So, meron kang chlorine and C3H6. Okay, ibig sabihin, may natitirang chlorine, may natitirang C3H6. So, malamang isa dyan ay excess and also yung ating degree of completion ay hindi 100% kasi may natitira sa kanilang dalawa right? And the products which are C3H5Cl, okay, HCl and C3H6Cl2 dun sa pangalawang reaction, well, alam din natin yung kanilang composition or amounts, okay? Now, let's say na ang desired product here, kasi nga parallel reaction to, pero ang gusto talaga natin na ma-produce ay C3H5Cl. So this one, which is coming from the first reaction. Okay, ano ang pwede natin maging basis dito? Okay, so let's write the good basis. Ang basis natin, usually di ba ang basis ay kung alin yung given or alin yung stream na pinaka-known. Okay, and therefore it should be the amount of product. Okay, so alam natin yung amount and composition ni product. So yun yung ating basis. Okay, let's do this one medyo one by one. Okay, so ano yung pwede natin calculate? Isa-isa natin. So letter A, how about we calculate first yung chlorine gas na pinasok? Alam naman natin lahat ng mga lumabas, ng mga product, pero ilan kaya yung pinasok na chlorine, ilan kaya yung pinasok na C3H6? Okay, so C amount, okay, or moles of Cl2 fed, okay, which we would like to look for in this part of our solution. Paano yan? Of course, kung ano yung lumabas na chlorine, which is 141.0, malamang more than that yung pinasok. Okay? So, yung pinasok ng chlorine, meron part noon na nag-react and then meron na sumobra. Okay? So, in mathematical form, it's moles of chlorine after the reaction plus moles of chlorine na nag-participate sa reaction 1 plus moles of chlorine na nag-participate sa reaction 2. Okay? But we need to find kung ano yung moles of chlorine na nag-participate sa reaction 1 at sa reaction 2. So how do we exactly do that? Okay, so let's write it here. Moles of chlorine na nag-participate sa reaction 1. So paano yan? Well, if you take a look at the first reaction, which is this, okay, malalaman mo yung moles of chlorine na nag-participate sa reaction na yan. Kasi alam mo naman yung amount nung C3H5Cl tsaka ng HCl. Okay? So ilan nga ba sila? The C3H5Cl, according to our diagram here, okay, ay 4.6. So 4.6 moles. Okay? And then ano yung relationship nila? Based on the reaction again, it's 1:1. Okay, so therefore you have 4.6 moles of chlorine gas na nag-participate doon sa reaction 1. Now, punta tayo sa reaction 2. Okay, so sa reaction 2, well, sorry, reaction 2. Ayan. So, well, isa lang naman yung product sa reaction 2 di ba? Yung C3H6Cl12. So, kung alam natin yan, di malalaman natin yung Cl2 or yung chlorine gas. So, ilan ba yan? C3H6Cl2 is 24.5. Okay. So, 24.5. Ano yung kanilang relationship? 1:1 pa rin. Okay. So, therefore, 24.5 moles of Cl2. Okay? So, finally, i-substitute natin yan dun sa equation na to. Okay? So, moles Cl2 fed is therefore moles of Cl2 after. So, ilan ba yung moles Cl2 after? Ayun, 141.0. Plus yung dalawang to. Okay? Plus 4.6 plus 24.5. And you will get 170.1. Okay, so yan yung pinasok na chlorine. Okay, so malapit na natin therefore ma-solve yung material balance. Kasi basically, pag sinabing material balance, you just have to calculate the amount sa lahat ng stream and their composition. So, kulang na lang, calculate natin yung pinasok na C3H6, yung isa pang reactant, and tapos na yung material balance natin. Okay? So, let's do that. Isunod natin yung moles C3H6 fed. Okay? So, ganoon din, no? Moles after plus moles na nag-participate both kay reaction 1 and kay reaction 2. Erekta na natin. So, moles C3H6 after, okay, after the process, yung C3H6, meron pa natitirang 651.0. Okay? So, 651.0 plus yung nag-participate kay reaction 1, paano yan? Well, di ba 4.6 yung product kay reaction 1? Okay? Times 1:1 yung kanyang relationship kay C3H6. Now, kay reaction 2 naman, yung product ay 24.5. Diba? Again, yung product na tinutukoy ko dito for reaction 2 is C3H6Cl2. For reaction 1, it's C3H5Cl. Ano ang relationship? 1:1 pa rin. Okay? 1:1 with C3H6. So you just have to look at the equations. Okay? And therefore, 680 daw. Yung mako-compute mo dito. Moles of C3H6 na pinasok. Ayun, we are done with the material balances. Kompleto na siya. Pero I'd like to calculate a few other things. Let there be. Alamin natin yung alin yung excess reactant, alin yung limiting reactant. Okay? So, paano nga ulit siya gawin? You have to compare the stoichiometry or the ratio na malalaman mo or makikita mo sa stoichiometry versus dun sa available na ratio. Okay? So, ano yung stoichiometric relationship ni Cl2 kay C3H6? Sila lang naman dalawa yung reactant, di ba? So, 1:1. Okay? Pero yung available, so sa una hindi natin alam, pero ngayon na-solve na natin yung material balance, malalaman na natin yun. So, Cl2 over C3H6. Okay? So, ilan yung Cl2, di ba? Yan yung 170.1. And yung C3H6, yun yung 680.1. So, kapag sinimplify mo ng konti, 0.25 over 1. Ano ibig sabihin yan? So, yung stoichiometric ratio nila 1:1. So, kapag mayroon kang 1 mole ng C3H6, okay, dapat 1 mole lang yung kailangan mo na Cl2. Pero dito, may 1 mole ka na C3H6, kaso 0.25 lang yung Cl2 mo. Hindi siya umabot ng 1. So, therefore, malamang Cl2 is the limiting reactant. So, limiting reactant is the chlorine gas, and the other is the excess reactant. So C3H6 yung ating excess reactant. Okay. Ano pa? Letter C. Let's try to calculate this time yung conversion. Okay? F. So remember, ano yung conversion? Ano yung kanyang formula? So the conversion is what? Moles reacted over moles fed. Okay? Moles reacted divided by moles fed. So in this case, let me highlight this one para sorry. Okay, yun yung ating equation for the conversion. Okay, now, for this particular example, ang gusto kong hanapin is yung conversion ni C3H6, okay, to C3H5Cl. Kasi pa pwede rin naman ang conversion ni chlorine gas to C3H5Cl. Okay. So, ilan ba yung moles ng C3H6 reacted? Okay. So, ilan yun? Saan natin siya makakuha? Eh, nasolve natin yung kanina. Ito. Moles. I'm sorry, no, not that one. Ito pala. Sorry. This portion, right? Okay, so kung maalala ninyo, saan galing yung 4.6? If you look at the reaction, okay, ito sa C3H6. Okay, so you can calculate the amount in moles ng C3H6 based on for reaction 1, C3H5Cl, and for reaction 2, it's C3H6Cl2. Alam naman natin yung mga amounts ng yan. So C3H5Cl is again 4.6. And yung isa, yung C3H6Cl2 for reaction 2 naman, ay ito. So CHCl ganoon din, 4.6. Okay, so dyan nakukuha yan, right? So kung ibig sabihin, yung nag-participate na C3H6 is 4.6 times 1 is to 1. Okay? 4.6 times 1 is to 1. But ilan yung nilagay na C3H5, sorry, na C3H6, di ba? 680. 680 siya. Ayan, so you will get a conversion value of 6.76 times 10 raised to negative 3. Ayan ang ating conversion. Okay. Ano pa? Let's try to calculate naman next yung tinatawag natin na selectivity. And I'd like to calculate the selectivity of C3H5Cl over the other product, which is C3H6Cl2. So ganoon lang, just have to take the ratio of these two. So 4.6 divided by 24.5. And it will give you 0.19. Saan galing tong 4.6 at 24.5? Ito yung amount ng product. Okay? Amount dun sa product na makikita mo. Yield. So, maraming paraan paano makuha yung yield. But I'd like to calculate the yield in terms of gram C3H5Cl per gram of C3H6 fed. Okay? So gusto ko ng ganyang format ng yield. Although, again, Gaya ng na-discuss ko last time, yung usual na calculation yield is basically yung actual divided by the theoretical or the maximum. Okay, but in this format ng yield, so let's solve this one. Yung gram C3H5Cl, okay, is, di ba, naalala nyo, 4.6 yung nakuha natin na moles of C3H5Cl. Kaso gusto natin gram per gram. So, kailangan natin convert yung 4.6 moles of C3H5Cl to the gram. So, that will give you, that you will need the molecular weight, which is 76.53. Can I just to be clear again, this is the molecular weight of C3H5Cl. Okay, divided by gram ni C3H6 fed. O yun. Di ba 680.1 yung moles? Di ba? Na feed natin. Okay? Eh, gusto natin ng grams. So, convert natin siya to grams using the molecular weight of C3H6. So, 42.08 ang nakuha ko na molecular weight. Okay, and just to be clear, this is the molecular weight of C3H6. Ayan, and finally, if you will use your calculators now, you will get the value for yield as 0.012, okay? Gram of C3H5Cl, which is the product, per gram of C3H6 fed. Okay, last na. Extent of reaction tayo. Now, remember, there are two reactions here. So there will be two extents of reaction. Okay? So sa extent of reaction 1, okay, you will have to base that on C3H5Cl. Okay? Kay reaction 2, kung ano man yung product na na-form, which is C3H6Cl2. Okay? But if you base it on C3H5Cl, diba? Naalala nyo sa extent of reaction, yung moles ng C3H5Cl after the reaction minus initial, wala kang pinasok na C3H5Cl, divided by 1, 1 being the, ano ba siya, yung kanyang stoichiometric coefficient, and it's a product, therefore positive 1. So 4.6 yan. Now for extent of reaction 2, iba naman to kasi iba yung value niya kasi ibang reaction siya. Now i-base natin siya sa C3H6Cl2 kasi yan lang naman yung napoproduce dun sa second reaction, di ba? So doing this, di ba, 24.5 daw yung after the process, di ba? Yung nakikita mo dun sa product stream, 24.5 yung kanyang amount. Minus 0 kasi wala ka naman pinasok na C3H6Cl2, and yung kanyang coefficient ay 1 also, positive, kasi product siya. And you will get 24.5. So these are now the extents of reaction for the two equations. Okay, so far ang ating dalawang previous problems ay medyo simple lamang. But in the next videos, we will discuss how to completely solve material balances involving reactions utilizing three methods. The first one is what we call extent of reaction method. The second one is atomic balances, and the third one is the species balances. So isa-isa natin siya, and it will culminate in a problem that we can solve using all methods.